Hi, good evening, everyone. Thank you so much for joining this session. My name is Mohit, and I am the instructor at Cognixia. We can just go through this. And if you have any question related to anything which you are seeing right now about Cognixia, there would be, I think, the email address which will be sent out to you. You can just communicate, you can write down, there would be numbers, you can talk to the people. But yeah, we would start about blockchain. So, yeah, topic for today is blockchain and its infinite possibilities. So my name is Mohit. I'm a certified blockchain developer, architect, and I have been training on blockchain since last 3.5 years. I'm also a co-founder of a community called Decentrum, where we do cohorts on blockchain. I'm part of Cognixia from last close to 2.5, 3 years now, and we have done multiple trainings for different corporates, and we have done demos or sessions on various topics related to blockchain, be it decentralized finance, be it blockchain fundamentals, be it on Ethereum, be it on private blockchain specific to Hyperledger. So we have done sessions, various sessions. I specifically have run multiple faculty development programs for different institutes across India, and also very, very specific cohorts, especially for Decentrum, which is one of the open community on blockchain in Hyderabad. Okay, moving forward, yeah, that's about me. Moving forward, what are we going to cover? What is blockchain? How evolution of blockchain happened? What are the fundamentals of blockchain? What all components are there in the blockchain? How exactly it works? So we'll pick up the first blockchain because it is very basic. I don't expect anybody who's joining the session today to know what blockchain is and how exactly it works. Many people don't know, even though they transact on blockchain, but still we'll see that how Bitcoin works, and then you can run parallel. So whenever you go and dig deeper into different public or private blockchains, the fundamentals are same, features are same. It's just that the way the different blockchain platforms works are different. So you can, if you understand Bitcoin, you can go and explore about different platforms, public and private, and then see and run parallels to what Bitcoin does and what other platform does, how they tweaked to solve problem which Bitcoin could not solve, or solve problem which are specific to those platforms, right? So that is something which we will do today. We'll talk about what are public, private, hybrid blockchains. We'll talk about what are crypto assets and what the future looks like. And some, I mean, if time permits, we would look at some case studies very quickly about the use cases, what are NFTs, what are probable use cases in metaverse and beyond, right? So very quickly, if we go back to time and see, I mean, what is I mean, how exactly everything started, right? So the internet revolution, or World Wide Web. So internet was initially a system where you could put information, right? And people can read information. So World Wide Web was kind of an information system which actually helped users of internet to access that information via something called as URLs, right? We type google.com, yahoo.com, facebook.com, instagram.com, and then we get that information. So how to access that information on internet via URL is something which World Wide Web has provided. So then after World Wide Web, the actual internet or .com revolution started in early 1990s, and then lots and lots of internet .com based companies appeared, and then all of those companies depend on a model which I'm sure you all know about, is client server model, where you have I just change it to pointer, so that, yeah, easy for me to point. Yeah, so there's something called a server, central server, which contains all the computation power, all the resources, all the data, and all the dummy machines which are clients connect to that server to access those resources, those data, those computation power. And this is how Google, Gmail, Facebook, everything, or Amazon, everything works, right? But the point is that everything is centralized. As I told you, the documents, the resources, the computation power, everything is centralized. just client access those resources from the centralized servers, and they are typically governed by TCP/IP, HTTP protocols. We all know that. The limitation. What is the limitation of a model like this? Limited computing power, right? In Facebook or in Google, so there was a time that on every month or every day they were adding new servers like crazy. There was a growing number of users who were getting onto the platform. Now that growth is stagnated, but still, you can see likes of Amazon and all, they're still growing. And even a lot of other services of Facebook, like Instagram, and also they're also still growing. WhatsApp is growing. So to 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 uh, to cater service, to cater to the demand of that ever growing customers, they had to keep adding a number of servers on their data centers. So Facebook has, or Google, every big .com company has data centers across the globe, and then they add thousands of servers every month, every year, to just satisfy the services which they provide to their billion plus customers, right? In this model, the limitations are efficiency and scalability. You can't just scale. You have to add more machines to scale, or to provide services to your users, right? Now, the next kind of model which we talk about is peer-to-peer model. Here in this model, you have only peers. There is no central server. It is decentralized, and it is distributed. The resources are distributed, right? So there is no single point of failure. On the other side, although there are huge amount of servers, if one is down, the other one will take over. There's a load balancing and whatnot. I mean, those are very, very complex architecture, and then it is not easy to break down those systems. So very, very complex build, but the limitation is that they're centralized, right? But here on something like something, if something is based on peer-to-peer model, there's no central server. So all the resources are distributed. You talk about the compute or the data or any document which is here is distributed. So everybody, all the machines are a server as well as a client. So if the first peer-to-peer application which has known to come about and became famous is something called as Napster. So this was created by a group of students in California. Some I think there's some university, some top university where some students build the platform called Napster, which was a peer-to-peer music sharing application where they where you can put music. So and anybody on the network can access that music from the website. So they become very, very hit. So I think the week they launched, they choked the whole university network. But eventually they went out of the university. They became public company, not public listed company, but they formed a company, and then they started giving service outside, and then they were eventually sued by music companies, and they had to shut it down in early 2000. But they made a point, and then how these kind of application can still be used. So the second one is BitTorrent. I'm sure everybody would have used it. So BitTorrent is also peer-to-peer based. We all have used it to uh, to download movies before Netflix and Prime Video became famous. And then if you talk about these two services, these are sharing, these help share files, right? So and then so these all these services were used to share some files. So if if uh, if I share as Mohit, if I share music file to somebody else, then I would also have it. The other person who has received it would also have it. Same in BitTorrent. You all have used that. Yeah, this is a general purpose file sharing platform where you have one file, you share it with somebody else, and then both the people would have it. Can be used. Then there was discussion which started early 2000. Can peer-to-peer network can be used for something like exchanging anything of value, right? You use bank to transfer funds, to exchange anything of value. Money is value, right? can we use something like any peer-to-peer system? Because if you exchange anything of value, even let's say that you are transferring ownership of your car or a house or land or maybe anything, you're purchasing anything, you're exchanging value. Can this happen on peer-to-peer network? So there were discussions on this, and then a lot of studies, a lot of research, and then eventually in 2008 there was a paper launched on Bitcoin, so electronic peer-to-peer transaction system. So there was somebody who wrote a paper which describes that how anything of anything of value can be exchanged via peer-to-peer network. So it was first digital currency experiment where you have a currency which can be exchanged on a peer-to-peer network. And this is also a first blockchain innovation as well. And it is designed by somebody called Satoshi Nakamoto. Nobody knows who he is. And it could be a single person or a group of people. He was very active when this paper was launched, when the network brought up in 2009, January. And then he was very active in early till 3 years, and then he disappeared. Nobody knows where he is. And the account which holds Bitcoins worth of billions of dollars are still there, which is on the on his account, right? And the white paper called Peer-to-Peer Electronic Cash System. This was published in 2008, and then the network was brought up in 2009. The first Genesis block was mined in 2009, right? So what is mining and all, we'll talk in a bit, but this is about Bitcoin. So this was the first application where anything of value could able to exchange on a peer-to-peer network. That was something which caught everybody's eye, and then we know rest is history, right? So right now the price of Bitcoin is close to $20,000, and in Indian rupees is 1600,000, and the market cap of Bitcoin is $374 billion. This was at one point of time about to cross or crossed $1 trillion. I've seen 900 billion as well when the price touched close to $70,000. But yeah, it went down. It's a highly volatile market, and price goes up and down very, very fast. So total number of Bitcoins which are ever going to be there is just 21 million. There won't be any more, any less. Eventually, there will be 19 million or 21 million. And right now, there are 19.1 million Bitcoins which are in circulation. So there are some Bitcoins which gets added every 10 minutes. When there is a block gets added to a blockchain, we'll see how. That is what actually, that is the reason why I have put all these numbers here, so that we can, while discussing today's topic, so that there's something for you to take away, that how Bitcoin works. When you walk out of this session today, you would know that yeah, everybody talks about Bitcoin. Now I know how exactly it works. So we'll discuss that today. So now, I mean, these are the numbers that they're going to be 21 million. Why 21 million? We'll talk about it. Now, currently mined Bitcoins are 19.1. Why 19.1? We'll talk about it. How it is growing, we'll talk about it. So you would know that yeah, there is a blockchain. Everybody talks about Bitcoin. Everybody talks about Bitcoin price. But why this price is going up and down? Why there is a value associated to it? Why 21 million? Why 19 million? Why there's going to be, it would stop at 21 million, and then how anybody, and how exactly this whole ecosystem works. There is no bank, right? The way conventionally we know about currency is via banks, right? Via central banks. In India, we have RBI. US, we have Fed. That there is a central bank which issues currency, and then that is exchanged via banking network, banking system, and then every country has its own currency. This is how we know currency, right? This is how we know money, right? So this was something which changed the definition of currency, right? Or money, and then how everything, without having a single bank or single authority, how everything is being exchanged. So we'll talk about that. And then now Now you know that countries are coming up with their own cryptocurrency. So India has announced their crypto. This is called as CBDCs. I'm sure everybody would have heard about it. Central bank digital currencies in last year budget. In this year budget, in February, they talk about that there is a project which RBI has started, and by 2023 they are going to launch the currency. China is already way ahead, and then there are many more countries who are working on their central bank cryptocurrencies, right? Digital currencies, and yeah, so that is something about Bitcoin. Why Bitcoin became so famous? A very quick note here on this is it is not physical, right? It is not printed like rupees, dollars, or euros or pounds, right? So it is just digital, and it can only be exchanged digitally. And every coin has an identity, and every coin has an owner. You cannot change it, or nobody can steal it, right? So every coin which is there, you have your, if I have coin or multiple coins or some portion of coins, I am attached to coin as an owner, right? My private key is attached there. I have signed, and then nobody can take it from me. That's that's how it is. Only owner can spend the coins. Yeah, that is different thing. If your private key is compromised, then yeah, it is compromised. But yeah, if you have your private key, then it is always yours. You can't carry it in your pocket, or you don't keep it in your locker or house, or store it safe and all. So it is controlled by community, not by government. So there is a working group who actually control the future developments in the Bitcoin network and software, and it is no government which can control it. It is all about algorithms, mathematics. Some piece of that algorithm, some piece of that mathematics is something which we're gonna see today. But yeah, it is much more than that. But something which we need to know, that how things are working at higher level, is something which we're gonna discuss. But it is all mathematics and algorithm. It is not the government which takes a decision when economy is down, or there is uh, uh, economic slowdown, or any problem like uh, like 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 pandemic. You just, governments can go and print money. It's not like that. It is it the new minting of Bitcoin happens with its own pace. So that's how it is. And network is public, source code is open, anybody can go download and then see how it works. But now, that was Bitcoin. But what is blockchain, right? The technology underneath is called blockchain, and Bitcoin is a first application, first experiment of this technology, right? So blockchain is a distributed ledger that maintains a continuously growing list of ordered records called blocks, which uses cryptographic validation to link themselves together. So it is nothing, just list of records. It's kind of a ledger, which ledger is there in banks. Ledger is something, the entry record keeping in the form of blocks. We just store this big ledger in the form of block, and then those blocks are linked together cryptographically, so that nobody can break into the block and then change any data. So that's the definition. If you have anything where you have you have a ledger which is a continuously growing list of ordered records kept uh, and stored in blocks which are linked in the form of with the cryptographic lock is blockchain. So there are two things to it. There has to be a network, decentralized network, and a immutable ledger. So for any blockchain project, you have to take care of these two things: just a network and the ledger, which has the actual data. So these two things are taken care of. That means your project is taken care of. And there are a lot of well-known technologies have spoken a lot about blockchain. It's going to be a big invention and all. So that's that's it. So now, features of a blockchain technology, right? So first feature, if we talk about, is decentralization. It is one of the main feature of this technology, and one of the reason of its strength, that it is decentralized. There is no central uh, authority maintaining a network, or central authority controlling a network, or controlling any process here. So that's decentralization. It is secure, so any data which is put on blockchain is highly secured and safe. Immutability, any data which goes into this ledger could not be modified later. Transparency, whole transactional data is viewable, traceable, and anybody can go get in and then see what is there on the blockchain. Efficient, yeah, this is a faster and more efficient way of transaction, right? So these are the five main features of a blockchain. You will find numerous blockchain platforms which do not offer all of this. So 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 uh, so this is what a blockchain is. Then there are a lot of platforms which claim themselves as distributed ledger technology, which is ledger which is distributed, but might not provide immutability. There may be a ledger which might not provide complete decentralization, right? There may be a ledger which doesn't provide transparency. This is what Bitcoin is, this, right? Ethereum is this, but not every other blockchain you find, or every other distributed ledger technology which you find, offer all these five features. This is something which is important, that what you call blockchain and what you call a distributed ledger, right? Distributed ledger, blockchain is subset of distributed ledger, but distributed ledger is even bigger, right? So you may find platform which is built to suit the use cases which only require, let's say, decentralization, security, and efficiency. Maybe they don't need transparency and immutability, right? Something which is built for, let's say, enterprise grade processes to build synergies between enterprises, organization, and they want to build a system for those set of, let's say, banks or organization or some kind of an industry, and then do it. They don't need it to be immutable, the network or the data to be immutable. They should be able to mutate it. And then there has to be something which is, they don't need transparency, because they don't want everybody on the network to be able to see uh, what data that network contains. So this could be possible, and then they would be using these three features of blockchain and then build a platform, and then then they go and build a use case, develop a solution, and start using it, which is perfectly okay. But if these five features are there in any system, then you call that platform or that network as a blockchain network. So this is something which is important. If you keep in your mind that these five things should be there, then you call that platform, that network, as a blockchain network. Otherwise, it could be part of the distributed ledger technology, right? Okay. Yeah, just maybe you can pause for a 30 seconds and then take a look, absorb it, and then we'll move forward. And now, after this slide, I'll move on, go back to Bitcoin, and then we'll see that why Bitcoin satisfies all these five, right? Why do we call uh, this a blockchain, and why do we call Bitcoin a blockchain, right? And then why all this satisfies. Then we'll definitely move to the higher component level. But yeah, from basic high level, conceptual level, I'll tell you that how Bitcoin works. Then we'll see the components, and then as a component, we'll see what Ethereum also has and the other platform also has. Right? Okay. Next, yeah, why blockchain? Uh, Fine. Yeah. So actually, there was an animation here, and then this animation is lost. But yeah, you'll get the feel of it, right? Let's say there are two people. One is Steve, another one is Brad, and Steve wants to transfer $1,000 to Brad, right? How do Steve do it, right? Steve would need something called a trusted third party to do it, maybe a bank. Steve would go to bank, and bank would say that Yeah, I mean they both are in different countries. It's a cross-border payment system. It's not like our UPI. UPI is also going to be taxed, and then there will be a cost over there. But still, anyways, I mean, if you think of a cross-border payment transaction, and then there is a Steve, and then he goes to bank, and then bank says that yeah, I would charge a fee, and it would take 3 days for you. I mean, for me to transfer your $1,000, I'll take $50 out of it, and then I'll transfer 950 to Brad. This is how I'll work, right? Now, this is not like a video call or an audio call how we are exchanging. It is a little more complex than that, and then that is how this complex network is being built across the world, right? And then this is how this transfer happens. Now, there are three problems that why do I need to wait for 3 days when I can do this video call, audio call whenever I feel like, right? Just a click of a button. Now I have to wait to transfer money because again, eventually at the end, it's all zeros and ones, right? It is lesser complex than doing a video call or an audio call, but still, it is taking a lot of time. Third party, why do I need to depend on a third party to facilitate this transfer? Then why do I need to pay higher fee to make this transfer happen, right? So just to give you some figures, the overall worldwide remittance market, the cross-border payment market is about $550 billion, and this is last year's figure or last year's figure. It would have increased by now. And then, as per World Bank calculation, for every $200 of remittance, it takes about 5% to 9% of a fee which is being spent to transfer every $200. So this is an average. So this is this is actually very, very, very high, right? So how we can solve this problem is something which we'll see via blockchain, right? And that whatever I'm speaking about today is how Bitcoin works. Ethereum works something similar, but it has a lot more advantages on top of it. But we'll see that how things happen in Bitcoin blockchain, right? So let's see the same scenario of cross-border money transfer. How does it happen if we are to do it on blockchain, right? So first concept is about open ledger. Let's say there are four people who wants to do this kind of an exchange. Steve, Brad, Leo, Don. They want to build a system which is open. They don't want to depend on any central authority. They don't want to have a very high fee system. And then they want instantaneous uh, transfer of funds, right? And then they thought that, yeah, we'll have open ledger where, yeah, where everybody can go and see because it is open and it's a ledger which is a record keeping. It's a ordered list of records which they would enter, and then everybody would know that yeah, this is the ledger. This would work like a bank, and then you would know that how who owns what in a ledger. That's what was decided among these four gentlemen, and then they started to transact. And then they started with Steve having $100. Then Steve transferred $50 to Brad, and then it's a ledger. And then this is how they want to maintain the entry. They would add a record to a ledger, which is Steve transferred 50 to Brad. Then Brad transferred 40 to Leo. That again another record, another entry to the ledger. Then Leo to Don, another entry, and this is how all the entries are made. Then eventually, Steve tried to transfer 60 to Don. Then, as per this ledger, Steve doesn't have $60. So that's why this is not a legit transfer. This is not a possible transfer. So that's why it is marked in red. And then this is not possible because everybody can see that, yeah, Steve doesn't have $60. He cannot transfer it. So that's how this open ledger works. Now, if there is an open ledger, it has to be maintained somewhere. Where can this open ledger be maintained? If we have any single party maintaining this ledger, that eventually that party would become a bank. And that is where we don't want any bank or any central authority managing anything. So this is another concept, which is distributed open ledger. Ledger is still open. Anybody can go. It's transparent. Anybody can go and check what is there, who owns what was exchanged, what is the history. Everything is still open, but it is distributed, right? Let's say there are two volunteers. One is Steve, another one is Leo. They volunteer to keep this ledger and maintain this ledger. It's distributed because it is at two places, a replica of a ledger, but we don't need anyone centrally to manage this ledger. Otherwise, it would lose its purpose of having it open uh, and having building a system to do an exchange. So this is how uh, this is a concept of distributed open ledger where you do not need any central authority, and then there are volunteers in the network who would be managing the ledger. Now we have solved this problem. We know that yeah, how this is the exchange will happen. Now the another problem is that how Steve and Leo would maintain this ledger. First of all, that what is the incentive for Steve and Leo to be fair, right? If somebody's managing a ledger, I can write 1,000 or 1 lakh or whatever amount to myself and then become king, right? But that's not um, become rich. But that's not something which a network should have. So there has to be an incentive for volunteers like Steve and Leo to be fair in the system, and how they can keep this ledger in sync. So that's the another problem which is to be solved. If that is solved, then you can have a payment network or any data exchange network like this, where you do not need a central authority which can tax you or which can, uh, I mean, build their own rules to uh, uh, define their rules to do business, right? Which is what is not needed. So that is how that network can play. And then to to figure out what is the incentive and for these two gentlemen to be fair in the network, and to how uh, their ledgers are in sync is something which we look at now, right? Now, so to do that, we'll see a concept called consensus, right? How these two volunteers, or we can call them miners, will be in sync, right? So, so let's say that any particular stage on a network, we can call it Bitcoin network or a blockchain network. How this is the state of affair where you already have network which is up and running. There are some transaction which has already happened. There is a ledger which is maintained by miners. We call them miners, and they have those ledgers which are in sync and have those transactions. So if we talk about Bitcoin, Bitcoin has close to 40,000 miners across the world, and those are miners. So those are volunteers, and those are the places where the ledger is placed, right? So there are 40,000 copies of a ledger all across, right? So why those 40,000 miners play fair is something which you would see. What is the incentive to do that maintenance or keeping that copy, and how exactly what happens when you exchange or initiate a transaction. So let's say this is this is what is already in the ledger. Just for simplicity, I've put one record per per block. This, just think of it as a blockchain. There is a block which has record number one, where Steve has moved transferred $50 to Brad. That's the record number one. Then Broad has transferred 40 to Leo. That is record number two. But eventually, in the real Bitcoin blockchain, there are a lot of transactions which are clubbed together, and then they form a block. It is not just a single transaction. So so just for simplicity, I've just put it here. And then now, imagine Brad wants to transfer $10 to Don. What happens now? So if you know that this is how the network works, we know that how Bitcoin works. So and why everybody do what they do, right? So now Brad is somebody, I mean, just a normal user, and if he wants to transfer $10, or you say 10 bitcoins or 0.00002 bitcoins, whatever, uh, any bitcoin which is equivalent to $10. So what Brad would do, Brad would open his mobile phone, which has a Bitcoin wallet. He would scan Don's public address or address or account details. Just a scanner would do, scan, get the address, and put $10 and press the send button, right? What happens then, that Brad's wallet is connected to one of the miner, right? Any of the miner, and then it goes there, and then that initiates the transaction, right? Any node, it is connected to a node which initiates a transaction. There is a script that how a transaction script has to be there, which is a little more technical. We won't get into it, but that script has basically which defines that what is the sender's address, what is the recipient's address, receiver's address, and I mean that address is basically just a public key of receiver, and Brad's public key of Brad, and then uh, somebody who's a sender has to sign the transaction using the private key, and then using that private key that is signed, and then that is how a transaction script is formed. And then once a node, whichever node does it, then that node propagates to all the miners across the network. In case of Bitcoin, it goes into Bitcoin network, and via a exchange protocol, it goes from one node to all the other nodes. And then when it reaches all the nodes, they start mining that transaction, right? So mining the transaction means that all the miners, uh, in our case, just two miners, Steve and Leo, when that transaction reaches Steve and Leo, they start competing with each other to mine that transaction, right? So I'll just take a 30-second pause for you to digest whatever you see here on the screen. Then we'll see that when this transaction reaches the miners, then what do they do, and why do they compete, and what is it that they do to mine the transaction and then add that transaction to their blocks, right? Just 30-second pause so that you just digest what is being spoken. So now all, imagine that, yeah, both the miners here, Steve and Leo, has received that transaction. Now this is the transaction where you have the public address, you have the private address, and the amount which is being exchanged, and this whole transaction is signed by the private key of the sender, which is Brad, right? So now what these miners are fighting for is to find the X, right? So they have to find X, which is also called as nonce. Whosoever finds it first will win the block, right? And then that is what all the miners are competing for. They want to win the block, right? So now to win, to find X, what is X, right? They have to find X. What is that X? X is such that any number which satisfies the equation where this transaction is concatenated with that X, and the hash of this total text is less than the difficulty level of the network, right? So if you compute this hash of this thing, right? This transaction concatenated with that X, and then you hash the all of it. Whatever comes out should be less than the difficulty level of the network. The difficulty level of the network keeps on changing, right? So more the difficulty level, it is more difficult to find that X, right? So it is something like this would return some number, and then that number, just imagine that should start with zeros, four zeros. Now if you increase the number of zeros in that start, that means it becomes more difficult for you to find x. So this equation is such that you cannot just find x by solving the equation. You can only solve this equation by using brute force. I mean, by trying different values. You start with 0, then 1, then 2, then 3. Whenever this equation satisfies, that is the x, right? X is nonce. When you find a nonce, let's say Leo could able to find miner number 2 could able to find the x such that this whole equation, I mean, this whole expression is, is less than the difficulty level. Uh, and once he does that, he'll say that, yeah, I could able to mine the block, and then he sends it to everyone that, yeah, this is the x which I could able to find. I have mined it, and now you all store this x, and then store this block to your blockchains. I have also done that, and then they start working on the next block. This is how everybody does it. Now there are two things. First is about the difficulty level, why there is a difficulty level, why it is changing and all. So the way Bitcoin network is built is that, imagine, now we have talked about how mining is happening, right? Okay, before that I'll talk about that why everybody is competing. Whenever you win a block, you get the reward, right? And that reward started. So in 2009, we spoke about that when Bitcoin blockchain was started by Satoshi Nakamoto, it was in early 2009. So at that point of time, when there were very few miners and very few people on the network. So there were very few miners, and then for every successful mining or winning a block, there was a reward of 50 bitcoins. Imagine what is the price of that 50 bitcoins now. I mean, that you multiply that 50 into $20,000 or 15 to 16 lakh rupees. That's huge, right? But this is not how the case is right now. So at that point of time, it was very difficulty level was very low, and miners could able to mine using their laptops. But then the way the Bitcoin software is written is that every 4 years it halves the block reward, right? So block reward was 50 for initial 4 years, 2009, 10, 11, 12. In 2013, it reduced to 25. Then 4 years again, it reduced to 12.5. Then again, it reduced to 6.25. So that is the reward which is going on right now, right? So this is fourth 4 year period, and this is the block reward right now, right? But still, it is based on the value of Bitcoin. It is still very high, right? So and this is the opportunity. Every 10 minutes, a miner wins the block. Every 10 minutes, there is a block which gets added, and this is average time I'm talking about, right? That is the reason why, if it happens fast, Bitcoin changes the difficulty level. If it happens very fast, it changes the difficulty level or increases the difficulty level. If it happens very slow, or it takes longer, then it reduces the difficulty level. So this is the concept of uh, having a difficulty level, so that there is no single party who has the edge by having a higher computational power should not be able to just keep doing the work of just keep uh, mining and then taking control of the whole network, right? So that is the reason why difficulty level was introduced. Imagine that, you know uh, now IBM, Google has quantum computers, right? They can't, they can just do this kind of calculation, find the x, find the nonce very fast in just fractions of seconds, right? But then uh, Bitcoin network is also very smart. Let's say that if Google got into with all their data center computational power, if they got into it, they'll be they'll be able to do it in fraction of seconds. But Bitcoin network will get to know, yeah, there is somebody who's doing it very fast. Now, what I would have to do is I have to increase the difficulty level. Increase the difficulty level so high that even Google would take 10 minutes to with all their computing power and data centers, 10 minutes to solve a block, right? That is the reason why these big companies are not into this business. So this is how this whole thing works. This is the reason why there is a difficulty level, so that decentralization is there in the network. So it is decentral, and then you don't get into uh, 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 I mean, not a single party get the advantage of all the proceeds, or they should not be a single system, or node, or a miner mining all the blocks. That's the reason. And and that is how this whole 10-minute block timing is also maintained over the period of time. And the current block reward is 6.25. Now, the another question which we have an answer right now is that why 21 million, right? So now this block reward, so having a block reward is a way of creating money, of minting money. While mining, what you're doing is you're creating 6.25. So with every 10 minutes when we speak, so I think we started at 5:30. Now we are 54 minutes into this session, and there would have been five more new blocks added into a blockchain, Bitcoin blockchain, and then that would mean 5 into 6.25 new Bitcoins got introduced. And this is how this new money is coming into the system, into the circulation. So how many Bitcoins minted? When I showed you on that second, third slide, there was 19.1, right? So that is how that 19.1 came about to be. So if there is a number which is uh, if there is a number, and then we know that this is reducing, this is a geometric progression, and then we all have studied geometric progression. So if you have a progression, then you can find the sum of it, right? So there is every 10 minutes there is some number, and then every 4 years it gets halved. That is how that number of 21 million came about to be. So there would be a time when this reward become close to zero, and then there would be no new bitcoins generated when all the 21 million bitcoins are minted. And right now, so just 2 millions are waiting. And then the miners would be able to make money by having the exchange fee, the transaction fee. So there is a fee which is also charged. So when Brad is transferring $10 to Don, it is not just that Brad is doing it for free. There is a small transaction fee which goes to the miner as well, right? So eventually, once all the bitcoins are exhausted, then the transaction fee, miners would be able to make money. They would still have a skin in the game by having the transaction fee. That might increase, who knows, but there would be a system like that where they would be able to make money only by transaction fees, right? So this is how this whole synchronization of ledger also happens. That this is how new blocks are added, and then uh, all the miners on the network keep their ledgers in sync, because there is a work happened to add it. So there is a proof of work. This is also uh, the name of the consensus algorithm, which is proof of work in Bitcoin blockchain. So Ethereum also used to have proof of work as a consensus mechanism, which they have recently moved to proof of stake completely with the merge. You would have heard a lot about it, and this is how this whole network actually works. So uh, so this is how Bitcoin works, and a basic structure of a blockchain. So blocks in a blockchain. So every block has the header and the basic details about the block and all the transactions here, right? So this is transaction data. It could have multiple transactions. Let's see, if you see this example of block 2, it has a lot of transaction. Let's say that 4 transactions are there, and then transaction data is all the transaction plus their hashes are stored in the transaction data, and the root hash, I mean, the hashes of hash, root hash is stored in the Merkle root of the header, right? And every header also stores the hash of the previous block. And I would tell you why. Actually, this brings in the feature of immutability, right? And we'll see that how exactly it happens in a bit. But this is the basic structure which all blockchains follow. I mean, you go any platform, this is how the blocks are formed, and this is how the data and the header data is arranged. I mean, it is different for all, but the basic structure is same. Moving on. So this is a little bit about cryptography, which we have spoken, hash and few other things. How and what is hash and all. So if at all you don't know, I presume that everybody know what is cryptography, what is hash, but very quickly, or for all those who wants to refresh, what is the hash function, what is cryptographic hash function? These are the functions which takes input of any size, because we have spoken about hash a lot in how proof of work works. So just to tell you what is hash, because in the whole blockchain space or any space, I mean, um, hashing is how you store your passwords as well, right? So in your enterprise grade application, it is the hash which gets stored. It's not the real password, right? So yeah, this is cryptographic hash functions are functions which takes input of any size and produces a fixed size output. So that fixed size is 256 bit in case of Bitcoin, and this should be efficiently computable, collision free, puzzle friendly. So just for example, uh, this is this is the input. Let's say Fox is the input, and it goes through a cryptographic hash function. It produces an output something like this. If you enter any data, any kind of input, you put a one word or a complete sentence, it produces the same 256 bit as an output, right? So that's the hash function, and it is one way. If you know the input, you can figure out the output. If you just know this hash, you cannot figure out what the input is. You can just verify. That is the reason why passwords are stored as hashes, not the encrypted password. We call it encrypted, but it's not encrypted. They store the hash of the passwords, right? So this is how everything is done. If you just see that, yeah, just a minor change. If you see V to U and the complete digest, the output is completely changed. You cannot just figure out by looking at it that this could be the input. This is the input, just one letter change, and the output is completely different, right? So that's cryptographic hash functions for you. These are collision free. That I mean, so when I spoke about that, there could be any data as an input. The output would be 256 bit always, right? And then we are saying it is one way. That means for every transaction, you cannot find the input, right? So these are the possible inputs, which is a huge, big set of possible values. The possible output is very less because it's just 256 bit, which is still very, very, very big, but still it is much smaller compared to the possible inputs. Then that is the reason the collision free means that nobody can find. So if you have X and Y, two values, and then you're saying, I mean, there would be possible values such that h of x is equal to h of y, right? If this is the case, it just I mean, this would be true, but it's collision free when you can see that nobody can find x and y such that x and y are not equal, different values, but still their hashes are same, right? So a collision free function, hash function, is something that we cannot find x and y such that their hashes are equal, right? So that's the collision free. It's used in storing password. I think everybody knows about it. We don't need to worry. I will tell this. But yeah, one important point about hashes, cryptographic hash functions. By the way, Bitcoin and even Ethereum uses SHA-256 hash function, and they are puzzle friendly, because what puzzle friendly mean is, if this is the equation and we are saying that if x and y are known, let's say this is x and this is y, if you know both of these, the hash function is called, and this is hash function, is called as puzzle friendly if there would be no solving strategy such that this equation is solved by just trying random values. So if, I mean, there should not be any other solving strategy other than just trying random values for ID. If you want to find ID, you know x and y. You cannot find ID other than just trying values 1, 2, 3, 4, 5, 6, and then whatever satisfies the equation, you should satisfies the equation. Should not be any other way of doing it. That is what is something which miners do. If you remember, when we were discussing about that proof of work, what miners do, what puzzles they solve, is this. This is the equation they solve, and here ID is nonce, which we called x in our equation back there. So this is what puzzle friendliness means. And then for a blockchain, you need to have a puzzle friendly hashing algorithm, and that is how I'll just quickly show you what all we have discussed in a quick small demo, so that it will be easier for you to connect. Go to this portal. So if you see, this is that 256 bit hash, SHA-256. I just type something. I'll type my name. See this hash. I just change something. I just add one letter. You see, the hash is completely changed. Completely changed. This is how the hash is getting calculated, right? This is a small function which we have written. Just type anything and then see this hash is being calculated. This is just a hash function. I'll go to the block, a normal blockchain block, and how nonce is getting calculated. Just forget about anything being here. I'll just type whatever, any transaction. Mohit sending, let's say, X, Y, Z, how many, let's say 100 Bitcoins. Right? This is the transaction which I want to post. This is the data. Now this data, now all this together, this is the hash. Now we spoke about difficulty level, right? So what miners do is they take the data, the whole transactional data, and then they find nonce. I mean, that means this plus this should come out to be a nonce. Come out, the hash of this plus this should come out something less than a difficulty level, right? So how we define a difficulty level, that anything which starts with 40 is something, is a valid block, is what I say. So I want to find a nonce such that when it is concatenated with this data, this is my transactional data, it could have many more records, right? Sam is doing this transfer to, let's say, ABC, maybe 50 Bitcoins. There are two transactions in the block, and I want to find a nonce such that the final hash should come out with starting 4 zeros. That's my work. So what this system does is it starts with nonce as 1, then goes to 2, 3, 4, 5. It changes, and then see, every time it just calculates the hash and figure out that if it is starting with 4 zeros. If not, it tries the other number, fourth, fifth, sixth, seventh, as same, and then tries different numbers, and then come out to be have a nonce which calculates the hash which starts with 4 zeros. I click on mine, and then it will start mining it. That means finding a nonce. I'll just click, yeah. Now, I mean, it looks very fast, but it has done a lot of calculation. It has came out to be a 10269. This is the nonce, which is when gets concatenated with this data, and then the output hashes starting with 4 zeros. This is how a block is getting mined. Now we'll see this in a blockchain. You have a Genesis block. Let's say Genesis block, Mohit is having 100 Bitcoins is what we start. In Genesis block, there's no previous hash, right? Because this is the first hash, so there's no previous block to it. So it is previous hash is 0. Now I want to mine this block. Satoshi Nakamoto had done it in 2009 to mine his first Genesis block. I'm doing it here. Now this is mined. It has become green. This is the nonce, and this is the hash, which is starting with 4 zeros. Now another block. Next block is required to be mined. Now for next block should have a previous hash as a hash of the previous block. This is the hash of block number 1, 4 zeros, then B46DE, and then this is the this is placed in the previous hash of this block. We'll see that why it is done. But now when we do the hashing, this is also considered as some data, right, to it. So now I'll say the transaction is Mohit wants to transfer XYZ, how much? 50 Bitcoins. This is my transaction data. Let's say Mohit also wants to transfer to ABC 20 Bitcoins, right? So these are the two transactions. And so there would be miners who would mine it. I click this button, and then this would calculate the hash, which would start with 4 zeros. So it will calculate in nonce basically. You see, this is 35230. It will change. I click on mine. Yeah, this is the nonce, which calculates when concatenated with this data and previous hash. It calculates the hashes starting with 4 zeros. So same thing here. I'll just putting something randomly, and then I click on mine. You'll see that previous hashes are maintained. And then again, this hash, which is 40787A8C, it goes here as a previous hash. I'll just random data and click on mine. So this is how this blockchain is being formed, right? Now we see all the features, right? Decentralized, we spoke about blockchain's first feature, which is decentralization, which is that this blockchain would be stored at all the miners. In case of Bitcoin, it is 40,000. In any network, you have multiple miners, multiple volunteers, multiple nodes, and all the nodes would have the blockchain. So that's why it is decentralized. Second thing we talked about, transparent. Anybody can go and download this, connect to any node and then download this blockchain. It is transparent, so anybody can see, because there are so many nodes and everything is open. You can go and then check what is the transaction, so which is also okay. It is transparent, it is secure, and it is immutable. Let's see that how it is secure and how it is immutable. Now this data is stored here. Now we have, I just reduce the size, and this is still visible to you guys. You can see all this green. I'll just make this also green and mine this fifth block. All the blocks are here. Now imagine that somebody wants to, change any data. There is a miner or there's a hacker who wants to change this transaction. Instead of ABC, hacker wants to put his own name, right? And then he can just hack one node and try to change the data. See, as soon as I change anything, I want to see hacker, it made it red. That means now this hash is not calculating starting with 4 zeros. Now this hash has changed. It made a change here. In block 3, this also becomes invalid. Now this hash with the data, it is not coming out to be a hash starting with 4 zeros. This is how everything becomes invalidated. You change anywhere and everything becomes invalidated, which is why, and then all the other nodes who are connected to this node would figure out, yeah, this is an invalid data because it is not summing up the way it should have been, and now we should just disconnect it to it because this looks to be a compromised node. So this is how nobody can actually connect and take uh, data from this node. So that brings the security and immutability. You cannot go back and change data, because it would invalidate everything from there on, right? So this is how. And then if you cannot change any data, it'll remain as is. You cannot change it. That means it is also secure, right? So that brings those two features as well in the in this. So all five features. It is distributed. I'll show you distributed way of this whole thing. There is a peer A, node A, volunteer A, miner A. You can call it anything. Peer B, peer C. You put data. I'll just put in A, A. Just for example, you just mine it. So this is what is happening at all the peers, right? They're just storing this same data, same set of data. One would mine, and then that same data would go everywhere. Just for illustration, this is what it is. You have B, then you mine it. You see all the hashes are coming along very fine, right? This is how, and then everything will get calculated the same thing, same algorithm, and then this is how everything works, right? So if you change any data anywhere, let's say the peer B is compromised and then this data is changed, I'll just add one more thing. I'll just add third block also. Now this is how, let's say at one point of time, this is how the blockchain network is looking like. There are three miners. All three has three blocks each. It is distributed because the data is distributed at multiple nodes, and it is the efficient way of working because you don't have intermediary. That's the second feature. Then it is transparent. Anybody can go download the ledger from uh, peer. You can connect to peer and then take all the data and then also start working. That's transparency. And then security and immutability. You go and try to change any data anywhere. Change this data, this becomes invalidated. Peer A, peer C will get to know that, yeah, this peer B is compromised. Let us disconnect from peer B and then just keep working on. So that gives the feature of security and immutability as well. So this is how this whole thing works. I'll also show you the actual Bitcoin live network. Give me a second. Uh, Bitcoin Explorer. You can go to Google, click on Bitcoin Explorer, blockchain.com, actually. Yeah, blockchain Explorer. You can go to blockchain.com and click on Blockchain Explorer. This will give you a live blockchain Bitcoin or Ethereum data. This is this Bitcoin. This is the price. You know that this is the hash rate. These are the transaction every 24 hours. You will see the blocks. We're talking about blocks, right? This is the latest block. Uh, the latest block was added, which was 7,59,222nd block. So this is the block height. Height means that how many blocks have added to the blockchain right now, till now. And this was mined 14 minutes back. And then the one previous to it was mined 27 minutes back, then 32 minutes back, this one. So you see the average time. Last half an hour, 3. Last 49 minutes, around 6. So the difficulty level is changing. You see that there is a difficulty level which is changing, keep on changing. It is inbuilt in the network, and it maintains the average time which is being taken to add a new block, right? So this 1, 2, 3. Now we'll get into this block and see that what is this is the hash of the complete block, and there is one block added after it. This is the difficulty level of this block. This is the Merkle root, which we have seen in that slide where you have all the transaction and then the hashes of the transaction, and there is a binary tree containing all the hashes. And the root of that binary hash tree is the Merkle root. This is also stores in the header of the block. Okay. And block reward, we talked about block reward, which is 6.25 bitcoins. So these new 6.25 bitcoins which got created as part of this block, right? So that is thing. And fee reward, I also talked about the transaction fee. Very small transaction fee also uh, gets charged to the person who is transacting, and that transaction fee is also here, right? And how this comes about to be in, if you see, these are all the transaction, right? uh, the address, this is the address. This address has transferred 0.2304 bitcoins to these addresses. uh, these are the two addresses. One, this is the fee which is going to this, and this is the another, the actual address where it is going. So this is how this transaction looks like. These are the actual public keys which we spoke about, right? When Bob had to transfer to Sam, you scan it, and then this is how everything happens. So these are all the transactions. So as also I told you that there are multiple transactions which are clubbed together and then put into the block. So this is that actual real block which you're seeing, the live transaction which is happening, right? And then these are the lot of transaction. I'll go back to the page one. I'll go to page one, and you see that the person who has mined has got that reward, and that is also becomes a part of a transaction data. See, this is the reward which has gone to this user, and this is the block reward. uh, this is the block reward which this user himself has given him, that yeah, 6.409, which includes 6.25 fee plus 0.159 as a transaction fee, and then that transaction also gets added to a list of transactions. So when miner mines the transaction, mines the block, then he creates a block and added his own transaction and send it across to everybody, all the other miners, that now I have mined. This is the nonce which I've calculated now, and I've also added my reward block. Now you also go and store it into your blockchains. So this is how everything happens, right? So now we are very, I mean, this is maybe, yeah, this is something which you can go and explore yourself, but this is the place, is how you do it, and this is the real live action. Same thing is there for Ethereum as well. Uh, Etherscan. Etherscan is a site which you can go and explore whatever is happening for Bitcoin. Etherscan is for Ethereum blockchain. Very quickly to talk about what Ethereum is. Um, uh, I mean, the definition wise, Ethereum is is, um, is a world computer which is distributed Turing computer, Turing machine, but it is a blockchain, in simple terms, which also gives you a capability of building your own application, right? So, Bitcoin, the only use case is a cryptocurrency. It's a digital currency, nothing less, nothing more. But uh, Vitalik Buterin, who was one of the developer for Bitcoin also, and then he proposed that, yeah, why don't we build and enable this blockchain, Bitcoin blockchain, to be programmable. I mean, people should be able to program and then build their application on top of it, right? But that was not approved, and then he went ahead and then built his own blockchain. This is Ethereum, and then Ethereum allows you to build your application. You write programs on top of blockchain, and then use those programs uh, to be as your use case, which could be anything. I mean, you can use Ethereum to uh, store, I mean, anything of the exchange of value, right? So we spoke about money as an exchange of value, right? So for money to be exchanged, it's not like a music file or a video file or a movie file where I have a music file and I've shared it to somebody else. Now we both have it, but you can't do it like this for a money or for a car or for a house, right? So there has to be a debit and credit, and that is something which is maintained in ledger. And that ledger is something which Bitcoin provides for money, which is a digital currency, but it doesn't support anything else. But Ethereum, you can build that. What is that asset? I mean, you can define that asset. It could be money, it could be a car, it could be your degree certificate from university, from schools, your experience certificate from your employer, and then it can brings you a complete set of other opportunities, right? So uh, you can do insurance, right? You do insurance, you can have a contract, insurance contract saved onto a blockchain, right? And whenever there is there are the condition which meets for it to be executed, you don't need to run behind the insurance companies to get a claim. Yeah, you have an insurance, there is a valid data which proves that, yeah, I can claim the insurance. It is on blockchain, nobody can stop it. I mean, it is transparent, everybody can see it, it is secure. I can go and execute it, right? Imagine about your land registration, right? What if you have a house, right? We register it and we have the certificate. It is this data of registration of your house, of your land, is stored with the government. You have cars. The registration of cars is stored with RTOs of the state, and then that data is there in silos, and then that is how you prove your ownership, right? What if that all data is available on blockchain, and then you prove your ownership uh, right away, I mean, on the line, right? Which would be an authentic and serious way. You go to any, from one organization to another organization, and you prove that, yeah, you have worked in previous organization. There's a huge set of uh, what do you call, background verifications which run, right? One application where you can build your background verification. You don't need to do background verification if your data is available on blockchain. Some of the blockchain, I'm not saying that it has to be on public blockchain, it could be on private blockchain, right? But if that data is available and you want to validate that data, right? You don't need to go to background verification companies and run it, right? That can happen on blockchain. You validate that. So Ethereum is a platform, or similar platforms like Ethereum, gives you or enable anyone to define that asset. It could be your certificate, it could be your car, it could be your house, whatnot, right? If you can represent anything digitally, it can be created as an asset. Your car has a registration number, right? That number could be an asset, and that could be stored on blockchain and can be exchanged via blockchain, right? Or to be proven, your ownership can be proven on the blockchain. You have a license has a license number. It can be stored on a blockchain, and then its expiry, its authentication, its ownership can also be validated on blockchain. So that is the application, and that is the potential blockchain has, and Ethereum has, or any other platform has, where you can define the asset and define the rules that how that asset can be exchanged. And those rules are um, in terms of public blockchain platforms, Ethereum, it is called as smart contracts. You must have heard about it a lot. Those are the smart contracts which you can write on top of a blockchain. Those smart contracts, the way bitcoins are stored, we were showing this. You can write in Ethereum blockchain. I mean, I can show you there, but that smart contract, let's say any program that you're writing that x is equal to y plus 5 or 6, and then take that value of x, print it somewhere, or anything. I mean, any set of rules that you're writing, rule 1, rule 2, rule 3. I mean, this is a smart contract. That smart contracts lives on blockchain. I mean, you store that smart contract on blockchain. Now, because it is on blockchain, it is transparent, it is secure, it is it is immutable. All the features which are applicable for any data on blockchain, which we discussed, is applicable on any asset data as well. Data as well as the smart contract. Let's say that if you have an application which maintains your car registration, right? So the data of your car registration will reside onto a blockchain, plus the program, or we call it smart contract, which manages that data is also on blockchain. So that is also secure, and that is also immutable, and your data is also actually immutable. So that is the potential which platforms like Ethereum brings in. So that's why I wanted to introduce the concept of blockchain first and then introduce you to the different platforms. Ethereum is one platform, Solana is there, Cardano is there, Polygon blockchain is there. So a lot of, you must have heard a lot about decentralized finance, right? So I mean, in during COVID in last 3 4 years, the actual value logged in decentralized finance grew from few $1,000 to billions of dollars, close to 100, more than $100 billion is logged into DeFi platforms. So so the whole finance, whatever you do on banks, we in Bitcoin we just spoke about the just one transaction, right? But there could be, the banks or the financial institutions across the world offers a huge set of services, right? Products. All that can be written on a blockchain, because why do we go to bank? Because we trust them. They're regulated by central authority. What if we bring the trust via technology, because it has one, two, three, four, five features we talked about? Then technology itself gives that trust. If there is a trust, then you can go and then bank on them as well, right? So those are the application. Now there is a huge discussion around metaverses, right? Facebook has changed its name to a meta, right? Because they're banking on meta. They know that, yeah, this is going to be future. Not saying that metaverse is all about blockchain, but the exchange of value on metaverse would most likely be on something like blockchain, because it'll be a huge set of assets. Again, we're talking about assets, and everything in meta is virtual, right? It is virtual plus reality, how you represent that virtual into real beings, and then everything would be digital within those metaverses platform. And then how you keep a track of who owns what, and how would you exchange. So these platforms, blockchain platforms, gives you uh, uh, that trust, that facility to do that, to track it, to exchange it, and whatnot. So and the actual trust, that's where we are right now. And future, this is what anybody who's participating here can explore. From here, there are two things. One is public blockchain, where you have everything open, transparent. Then there is a private blockchain, which enterprises use um, within themselves, and then to solve some of their use cases. And um, and 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 there are two things. One is public blockchain platforms, Ethereum, Solana, Cardano. And private side, Hyperledger Fabric, Corda, multi-chain. So all these are there, which can be explored, and then you can figure out, yeah, whatever is the use case or whatever is a problem you want to solve. And always, blockchain is not a solution to every problem, but if there is a problem where blockchain is a well-suited solution, then you can think of that which side, it is public side or a private side, and then go and explore which platform, because every platform has its own pluses and minuses. There are platforms which are well suited for a certain use cases. Explore it, go there. So Hyperledger Fabric, if you want to go to a documentation, there is something called as how we say, read the docs. Read the docs, Hyperledger Fabric. You can go to this site and then read about what Hyperledger is all about, and then just put actually very well maintained documentation. You can go here for Ethereum um, consensus, and then ether.org also. Ethereum.org is also there. You can pick up how you can go about it. But yeah, in this Explorer, similar to Bitcoin Explorer, you can see the blocks, you can see the data, and then in this data, you can also see the smart contracts as well. But I think we are close to time.